Hey guys, so this is my fourth video on joint contest random variables. In the previous video I discussed two questions. The first question was on finding the PDFs and the CDF of a joint contest random variable, and the second question was on finding the expected value of a max function. In this video I am going to apply the concepts that we have discussed previously. This question is a little bit different, so just bear with me and let's just start. So this question says that let me just check if the recording is on. So this question says that two buyers bid for a single object in an auction. Valuation of a buyer is private information. However, it is known that each of them independently draw their valuation. Each of them independently draw their valuation from the uniform distribution. Okay. The auction rule lets the highest bidder take the object by paying the lowest bid. Suppose that the buyers bid truthfully, that is, the bid of a buyer is equal to her valuation of the object. Find the expected revenue of the auction. So we need to find the expected revenue, right? So we are given two bidders. So we are given, question is, we are given two bidders. We are given two bidders. Right, and let's just say that the bidders are x1 and x2, right? So xi, where my I is 1, 2, right? So there are two bidders. Let me just erase this and write this clearly. Right, so there are two bidders. Xi, I is equal to 1, 2, right? So there are two bidders, x1 and x2, right? And they're bidding for a single object in an auction. Valuation of a buyer is a private information. However, it is known that each of them independently draw their valuations from the uniform 0 to 1 distribution. Therefore, this xi and x2, x1 and x2, this x1 and x2 are uniformly distributed, right? So this xi is uniformly distributed from 0 to 1, right? So there are two bidders, 1 and 2, and the amount that they are bidding is x1 and x2, right? And all of these xis are uniformly distributed from 0 to 1. So they are drawing their distribution. Bids from a uniform distribution, which is they are drawing, each of them independently draw, so they are independent also. So we can say that xi is an IID variable, right? Independent and identically distributed. Both of these xis are identical, have identical distribution. That is the uniform distribution where they are distributed from 0 to 1, and they are independently distributed, right? So we can say that xis are IID variables. The auction rule lets the highest bidder take the object by paying the lowest bid. So for example, if x1 bids half and x2 bids 1 by 4, right? So we know that x1 is greater than x2, but the amount that x1 is going to pay, the amount that the first bidder, which had an amount equal to half, he will only pay the lower amount out of the two bids, right? So if x1 bids half and x2 bids 1 by 4, and the bid x1 of the first buyer, which is greater than the bid of the second buyer, then the first buyer will win the auction, right? So he wins the auction. Why? Because x1 is greater than x2, and he will pay only x2, right? So for example, we both of us are buyers, both of us are bidders, right? And you bid an amount, for example, let's just say any amount. I'm not talking about here a uniform distribution from 0 to 1. I'm just taking an example. I am bidding an amount 50 and you are bidding an amount 100, right? So what happens is your bid is greater than my bid, so you win the auction and you will be paying the amount that I tried to bid, right? So you will be paying 50. So this is clear. But because we have a uniform distribution from 0 to 1 and both of the bidders are drawing out their auctions, drawing out their bids from a uniform distribution 0 to 1, so we can only take the bids lying between 0 and 1, right? Suppose that, now we also have an assumption, suppose that the buyers bid truthfully, right? So you are bidding her valuation only, that is, bid of a buyer is equal to her valuation of the object. Find the expected revenue of the auction. Now we need to find the expected revenue of the auction. See, earlier I was talking about them drawing out their bids from 0 to 1 uniform distribution. I am sorry, let me correct myself. They are drawing their valuations, right? So your valuation and my valuation, if both of us are uniformly distributed from 0 to 1, both of us are drawing out our valuations independently and identically. Why identically? Because we have a uniform distribution from 0 to 1, both of us, right? So we are independently and identically drawing out a valuation from 0 to 1, and the next, and this statement is the game changer in this question. This statement says that suppose that the bidders bid truthfully, that is, bid of a buyer is equal to her valuation, right? So the bid and the valuation, right? So valuation is equal to bid. We both of us are bidding truthfully, right? So I am bidding my valuation, you are bidding your valuation, and both of us are drawing out our valuations from uniform distribution 0 to 1. Therefore, our bids are also being drawn out from the uniform distribution 0 to 1. Earlier, what I was saying is that they are drawing out their bids. No, they are drawing out their valuations. But because they are bidding truthfully, their valuations become equal to their bids, right? So bidding truthfully means, let me just erase this on the previous slide, right? So both of them are bidding truthfully. Let me just erase this also. Or let me just move on to the next slide. So both of them are bidding truthfully. Bid truthfully, right? So what happens is their valuation, which is x1 and x2 are their valuation, right? So x1 and x2 valuation is uniformly distributed from 0 to 1, valuation or xi, where I is 1, 2. So their valuation is uniformly distributed from 0 to 1, and they are also saying that they bid truthfully. Therefore, their valuation is automatically equivalent to their bid, right? Now the question says that find the expected revenue of the auction. Find the expected revenue of the auction. Now, I told you that if you are bidding x1 and I am bidding x2 and your bid is greater than my bid, right? First of all, the x1 and x2 are valuations, and we are bidding truthfully. Therefore, the valuation is equal to bid. The valuations are equal to the bid. Now, I am going to refer the valuation as bid, right? So you are bidding x1 and I am bidding x2, right? And you have valuation of x1. I have a valuation of x2. We both of us are bidding truthfully. So you are bidding x1 and I am bidding x2, right? But what happens is the amount that you are bidding x1 is greater than the amount I am bidding x2, right? So what happens is you will be paying the lesser amount of the out of the two, right? So whoever wins out of you and me, here you are winning because your bid is higher, but whoever wins from us, both of us, will be bidding the amount that the lower that the person who had a lower bid wanted to bid, right? So I explained you this. So now we need to find the expected revenue of the auction. This means that we need to find the expected value of a variable y, which is min of x1 comma x2, right? Now y min x1 comma x2, right? So if I am bidding half, you are bidding 1/4, I win the auction, but I am going to pay 1/4, right? This is the amount that I am going to pay, right? Now finding the expected value. For finding the expected value, we know that we need to find f of y into f of y. We need to find expected value, so we need to find e of y expected revenue of the auction. So this will become y into f of y dy, and x1 and x2 are xi's are uniformly distributed from 0 to 1. So therefore y is also distributed uniformly from 0 to 1 because it's the min of x1 and x2. Therefore we need to find this value. Ey is equal to 0 to 1 y into fy dy, right? This question was a little bit different but very easy. I just wanted to explain you again and again. I hope you guys got a point. Right, so now we need to find, first of all we need to find the CDF of y, right? So y was min of x1 comma x2. So for finding the CDF of y, f of y, we need to find probability of y, less than equal to small y. So f of y is equal to probability of min x1 comma x2 less than equal to y, and I have discussed this earlier also. You can check out my previous videos how to solve this. I've solved this earlier and I've explained how this all of this is happening. So what I can do is I can write this as 1 minus probability of min of x1 comma x2 greater than equal to y, and these are IID random variables, right? So I can write this as, I can write again, if you are not able to understand this part when I'm trying to find the CDF, you can check my previous videos. Not the, yeah, I guess the third last video, but just check that out. The video where I've discussed the calculating the CDF of min and max, right? That video. There you will get what I'm saying or what I'm doing here. So we need to find 1 minus probability of min of x1 comma x2 greater than equal to y, right? So I can write this as x1 greater than equal to y intersection x2 greater than equal to y, right? So probability of this. So f of y becomes 1 minus probability of x1 greater than equal to y, because these are independent random variables, and x2 greater than equal to y. So now what I can do is I can write this x1 greater than equal to y as 1 minus probability of x1 less than equal to y into 1 minus probability of x2 less than equal to y into 1 minus probability of x2 less than equal to y, right? 1 minus probability of x1 less than equal to y into 1 minus probability of x2 less than equal to y, right? So now what I'll be doing is, and we know that xi is uniformly distributed, right? And we need to find the probability of x1 less than equal to y, therefore the and x2 less than equal to y, right? So if I take probability of x1 less than equal to y, and we need to find the probability of x2 less than equal to y, which both of these will be equal. So we need to find the CDF, and we are given that xi is uniformly distributed. So this will become 0 to y, and this is uniformly distributed from 0 to 1. So this will become 1 minus 0 dy. So this will give me y into this will not dy. This will be 1 upon 1 minus 0, because we are finding the CDF of x, right? So dx. So this will give me x, and we need to put the limits 0 to y. This will give me y minus 0, which is equal to y. So my probability of xi less than equal to y becomes y. Therefore my f of y, which was 1 minus probability of 1 minus probability of x1 less than equal to y into 1 minus probability of x2 less than equal to y, this becomes f of y 1 minus y and 1 minus y. Yes, so now I need to find the PDF of y. This is the CDF of y, right? So this was the CDF of y. Now we need to find the PDF, which is small f. So for finding the PDF of y, what we need to do is we just need to find the derivative of the CDF of y with respect to y. This will give me small f of y equal to this becomes this whole f of y. If I just multiply both of these terms, this will give me f of y is equal to 1 1 minus y whole square, right? Now I need to differentiate this. This will give me 2 minus 1. This will give me minus 2 1 minus y and minus 1. So this will become minus becomes plus. So f of y gives me 2 into 1 minus y, right? And now I need to find the expected value of y, e of y, and the formula for e of y is y into f of y dy from 0 to 1, because y is also distributed uniformly from 0 to 1, because y is min of x1 comma x2 and xi's are distributed from 0 to 1. Therefore the minimum value of x1 between x1 and x2 will also be uniformly distributed from 0 to 1, which is equal to y. I explained all of this, quite quickly, but it is very easy. You guys would have gotten the point. You guys are more intelligent than me, obviously. 0 to 1. I emphasized on the point obviously because you don't know what you are. I took a lot of time to understand all of this. I still don't get a lot of things out of these, but yeah, I mean y minus y square dy, right? So this will give me 2 into y square by 2 minus y cube by 3. I just did simple integration here, right? So this was 2 into 1 minus y was my PDF into y. So this was basically f of y was 2 into 1 minus y. I multiplied it with y, and 2 was a constant term, so I just took out the 2 out of the integral, right? So I just performed simple integration and I got this term. So my e of y will become 2 into I'm just substituting the limits, 1 by 2 minus 1 by 3 minus 0, because if I substitute 0 in place of y square by 2 and y cube by 3, I will be getting 0 only, right? So this will give me 1 by 6, 3 minus 2, and I'll be getting finally 1 by 3. So my e of y, my expected value or expected revenue, finally my expected value e of y is 1 by 3. Therefore my expected revenue of the auction is 1 by 3. This was a very small video, and I took a very easy question. I want to make a video which was not that big, because in today's time we all have a very small attention span, and if I make a small video, I guess more people will like to see it. That's why I didn't extend this video. I hope you guys like the video. If you guys like the video, just subscribe the channel, share the video, and do put in a comment. It will encourage me to put in more videos. So thank you so much. I hope to see you in the next video. Bye bye.